Okay, let's try again. Okay, welcome back to physics. I wanted to go over some of the practice problems that are listed in the problem set for the first one you do. So it's the first time we're doing a little bit of algebra, so I'm going to walk through the classical problems and hopefully give you an idea of what I'm expecting. The answers to these problems are at the bottom, so everybody should get the answers right, but that's there for you to check. So show me how you got the answer, right? Just write the answer? Yeah, that doesn't count. You got to show me how you got the answer, and I'm going to be a little bit of a jerk about it at the beginning, sorry, but it's good practice for you and important to be able to do this. So here's the problem set that we're going to look at. So two sets. First one, some motion at constant speed. So an elevator ascends, constant speed of 4 meters per second. How much time is required for the elevator in order to travel 120 meters upwards? Okay, so let's do a couple things. So first thing I'm going to do, so it's always good to think about the formulas that you might be using. So far, we just have a few. So I'm going to have my displacement formula. So displacement, so delta x, change in anything is going to be my final minus my initial. So this is how we calculate displacement. We don't care what happens in between. It's just where you start and where you end for displacement. We have a calculation for speed, which is distance over time. And then we have a calculation for velocity, and this can be a vector. And if I'm really careful, I'll put an arrow over the top to indicate it's a vector, but oftentimes I just don't bother with it because it's too much work. So this is going to be my change in displacement over time. Sometimes we write delta t, change in time, but we always start at 0 for time. So these are three things that I have, and what I'm asking you to do is to write down these ones that you're using unaffected, and then to show me to manipulate the problem, the equation first, and then plug numbers in second. So let's go back to this. So an elevator. So we go. An elevator is going to ascend at a constant speed. So my velocity is going to be 4 meters per second. How much time is required for the elevator to travel 100 meters distance? So my change in displacement is going to be 120 meters. And the thing I'm interested in is time. Right? So this is what it looks like. So when I write these out, if you can do this part for this much for the problem, so this is problem number 3. So if you can do this much for a problem, so identify in there what they're telling you, right? Usually you're 90% of the way there, right? So now I'm just going to hunt around and say, well, what equation has these things in it? So this is my velocity equation. So what I'm going to ask you to do is to write down the velocity equation, which is delta x over delta t. I'm just use t. I'm going to solve for time. So how am I going to do this? I'm going to be careful about it. So I'm going to multiply time by both sides. So I'm going to have time times velocity is going to be delta x times time divided by time. Okay. And so I'm going to have delta time times velocity is delta x. And now to get time by itself, I want to divide both sides by velocity. I'll clean this up. So my time is going to be delta x divided by velocity. This is the most common mistake that people make. So rearrange it for something that's on the bottom. It's the most common mistake that's made in this class, right? Once you get used to it, it's not hard, but be careful about it. So the other way to think about it, right, I can swap these two. Right? So I'm solving for what's on bottom. I only have one thing on the left-hand side. So I can swap those two and end up with this equation. So this is what I'm going to ask you to show. So these are the two things I'm going to ask you to show me. You don't have to show all the intermediate steps if you don't want to. I'm going to ask you to show me the equation that you're using, and then that equation rearranged for the thing that you're trying to solve for. And now I'm going to plug in numbers. So now this is easy. So I'm going to have 120. I'm going to divide that by 4. And I'm going to end up with, what's that, 30? And I'm going to think about this. I'm going to have meters divided by meters per second, right? These are my units. You may recall that if I divide by a fraction, that's the same as multiplying by the inverse, right? So for my units, it's the same as multiplying meters times seconds per meter, right? And I'm left with seconds. Right? So the answer is 30 seconds, right? It's time. It's got to be in seconds, and the units will work out. And it's a good way to check your problem if you want to check your units, but make sure you have a unit with it. So someone can double check, make sure that's the right answer. I'm pretty sure it's good. So 30 seconds for something to travel, for an elevator going at 4 meters per second to travel 120 meters. Okay, let's do a couple more. So this is the idea I'm going to ask you to do, and I'll go through these a little bit more quickly. So a racing car. So number 4, I have a racing car. It's complete a 900 meter long lap in 15 seconds. What's the speed of the car? Okay, so let me be a little bit careful about this. So this is a lap now, so this is not a straight line direction. Some of the drivers going in a circle. They're giving me distance, right? So this is my distance traveled. I want to be careful that's not the same as displacement, which I'll use delta x for. So this is the distance traveled, this is the time, and I want to find speed. That's my unknown. Now I'm most of the way there. I'm going to take my equation that says speed is equal to distance over time. Look, I don't have to rearrange that, so I'm just going to plug in some numbers. I have 900 divided by 15, and I guess I got to use a calculator for this one. Not quick enough today. 900 divided by 15, and I'm going to get 60. What am I going to have? I'm going to have meters per second. Meters and seconds, meters per second. Okay. And that's my answer. I'll circle it and be proud because I got it right. I'm sure somebody check me. Number 5. And number 5, it is known that a shark can travel a speed of 15 meters per second. Oh, good grief, that's fast. Somebody Google that, see how fast that is. It's got to be like 35 miles an hour, maybe. 15 meters per second, that's pretty quick. So the 15 meters per second, and tell me this is speed. So I'll use S for that. How far can a shark go in 10 seconds? So that's going to give me a time of 10 seconds. And they're asking me to figure out how far it can go, right? So this is going to be the distance traveled, right? So it may not be in a straight line. This is going to be a distance traveled. Let's see what we got for this. So here we go. So I'm going to use my speed is equal to distance divided by time. I want to get to distance, right? So this is what I'm starting with. I'm going to multiply both sides by time. So time times speed is equal to distance. I'll rearrange that so I have it more pleasing way. Speed times time, right? That's the equation I'm going to plug into. I'm going to have my speed, which is 15 meters per second, and my time of 10 seconds. Notice my seconds cancel. I'm going to be left with 150 meters. I'm going to circle it, make sure there's unit on there, and celebrate my vast success in physics. I'm going to jump ahead in interest of time. So let me go over these other questions, which are around position, displacement, and velocity. So this is one question with a bunch of parts to it. So I have a balloon. It drifts at 140 meters towards the west. Okay, so I'm going to draw a diagram, right? And let me see, 140 meters to the west in 45 seconds. And then when suddenly changes, the balloon flies 90 meters towards the east in the next 25 seconds. Okay, what distance did it travel? What distance did it travel in each of those things? And what's the total distance traveled? Okay, let's tackle those three first. So, where'd you guys go here? There we go. So, I'm going to be careful, right? So sometimes with compass directions, I'll draw compass rows. Right, so this is north. Make this east, opposite west, opposite is south. So just to help me remember, but this is going east and west, right? So what's happening is traveling to the west and then to the east, right? So what's happening? My balloon starting here is going 140 meters this direction, and then it's coming back 90 meters. And so hopefully you can figure out that in the end, the total distance traveled is just going to be 50 meters, the distance between where it started and where it ended. So the displacement is 50 meters, total distance traveled, it's going to be much more than that, right? So I think that's what it's asking, right? Reminder, distance to travel. Yeah, so those are the first three answers, right? So it traveled 140 meters in the first 45 seconds. It traveled 90 meters in the second 25. The total distance traveled, is going to equal the sum of these, right? Which is going to be what, 230 meters. The displacement is going to be 50 meters. Again, displacement delta x should be my final minus my initial. So there's a mathematical formula for it, but yeah, we don't use it very often. What is the average speed during the first 45 seconds, average speed during the next 25, average speed for the entire trip? Okay, so my speed is going to be distance divided by time. I'm going to calculate speed 3 times. So speed for the first leg is going to be the total distance in the first leg, which is 140 meters, divided by the time it took for that 45 seconds. 90, so what's that? It's going to be like 3 point something. Yeah, I don't know, 3.1 meters per second. Speed during the second leg is going to be the distance it traveled in the second leg, which is 90 meters in 25 seconds, which is what, 3.5, 3.7? No, I should do, you calculate good numbers. Okay, 90 divided by 25, 3.6 per second. And total distance, so my displacement, my velocity, what are they asking for? Asking for velocity, or what is the average speed for the entire trip? So average speed for the entire trip is going to be my total distance traveled, right? This is distance, not velocity. So I'm going to be careful about this. It's going to be 230 meters divided by the total time, which is what, 70 seconds. And I'm coming with what, 230 divided by 70. Should I get 3.3 meters per second? Okay, the next set I think is going to be asking about displacement and average velocity. So be careful about this. So what is the displacement, and then it's the average velocity for each of those legs of that trip. Okay, so now I'm going to have this velocity, which is going to be displacement divided by time. And notice my displacement, well, I get to decide which side is positive and which is negative. So I'm going to say, well, let's make this direction positive. When I make that direction positive, then that first leg, my displacement for the first leg, we'll call it x1, is going to be plus 140 meters. That second leg, now I'm going in the opposite direction of my positive arrow. So this is going to be negative, right? So I'm going to be careful with this. So my position for my second, the displacement for my second leg of my trip is going to be minus 90 meters. And my total, then I just add these together, right? So x1 plus x2. So I'm going to add together 140 and add together my negative 90. I'm going to get my 50 meters, which is my total displacement. Now I do velocity. I'm going to have the same challenge of having 3 different velocities. So my velocity for leg 1, it's going to be 140 meters over 45 seconds. Right? I'm going to have the same speed and velocity, it's 3.1 meters per second. My velocity on leg 2, I'm going to have minus 90 over 25 seconds. So notice I'm going to have the same number, but I'm going to have the opposite direction. So I'm at negative 3.6 meters per second, right? So it's going at the same speed as we calculated in the first time, but yeah. And my total velocity is going to be much less, right? So my total velocity is going to be 50 meters divided by total time, which is 70 seconds. It's going to be less than 1, right? So I'm going to have 50 divided by 70, 0.71 meters per second. So even though you're going fast, right, it's moving at 3.6, 3.3 average, the velocity, beginning minus final, is going to be pretty small. Anyway, some example problems. The homework problems I'm asking you to do are nearly identical. So, yep, good luck and talk to you soon. Bye.